Hello everyone, welcome to the first ever virtual DDD. I've spoken at a whole bunch of DDDs over the UK, so this is a slight strange setup for me. I'm kind of used to have been out with a bunch of the speakers the night before and stuff, so yeah, should be interesting. Of course, as you've probably seen with all of the sessions, there's a code of conduct. Make sure you follow it, be friendly, be patient, be understanding, just so we can make this event as inclusive as possible. Of course, a lot of the sponsors that usually sponsor DDD have contributed their sponsorship this year to the National Museum of Computing, and you can donate too on the Just Giving link. I know I will be, so yeah, go and do that later, but also big thank you to the existing sponsors. And of course, use the hashtag DDD2020 when tweeting about sessions, including mine, and my Twitter handle will be coming up on a slide in a minute. So I am going to be talking today about breaking up with your dev machine. This is a sensitive topic. Developers get quite emotionally attached to their setups, I think, to the specific laptop or desktop they use, even down to, this processor is better or this brand of laptop is better than another. There's always been that kind of Mac versus PC thing, but we're going to go a bit deeper into it today. My name's Callum. I'm a Microsoft MVP and an Umbraco MVP. Umbraco is an open source .NET based CMS. I'm a .NET developer by trade. I run my own company here in the UK. I speak at a whole bunch of events all over the world. Unfortunately, can't travel at the minute, of course, but hoping that we can get back to that soon. I organize a few as well. I really love donuts, beer, anything unhealthy, and that's not done too well for me during the recent lockdown. But of course, I'm on Twitter, and throughout this talk, you can tweet me there, tweet me any questions, or put them in the Q&A below, and we'll happily answer them after the session. So think back to maybe the computer that you used to write those first lines of code. Depending on when you started, it might have been something like an Apple II, or a ZX Spectrum, or a Commodore 64. There's a whole bunch of machines that kind of came out in the 1980s that were starting to become more accessible. You could have a desktop machine. They were bulky. They were, very, very low powered compared to today, but they were fantastic technological innovations back in those days. You might have started writing, I don't know, BASIC or DOS. You'll probably have been familiar with these kinds of machines. And of course, if you were working in the 90s, you'll be familiar with these monstrosities. Just as we started getting a bit more compute power, they decided, we're going to separate the tower into this separate unit. And you probably had this disgusting beige, very bulky setup. Everything was beige: the beige speakers, the beige mouse, the beige keyboard and monitor. You probably have one of these on your desk. And then maybe if you were working as a developer in the 2000s, you would have had a machine, something like this. This was when portability started to become a concern. And especially developers I've worked with, I know people would have laptops that were, 3 or 4 inches thick, because typically the more power you wanted in a machine, the chunkier it would have to be. And therefore, developers were having these monstrosities that they would carry around, breaking their backs. And it would not be the most practical thing. But we started to get those kind of portable, more powerful machines. You're probably using this, depending on how your organization updates laptops and hardware, you're probably using these until the kind of 2010s. I think my first laptop was like a really chunky Sony Vaio laptop, and it was, you couldn't really carry it around. It weighed a ton. And then of course we come to the present day, or the kind of the 2010s, 20-teens, where we started to get these ultra thin, ultra light machines. We got what are they called? PowerBooks. We got the MacBook Air and the MacBook Pros, which are amazingly thin unibody machines. We have something like the Surface Pro and the Surface Book, which of course also solidified this unibody single metal design. Really nice, really portable, but can be insanely powerful. You can have gigabytes and gigabytes of RAM. You can have hugely powerful processors, and that's really cool. if you look at the past 30 years, that's a huge technological leap. And actually, you can see a pattern here where every 10 years we're having this sort of seismic shift in the way that developers' machines work, and the way that we would what kind of laptops we would choose. Just to give you a bit of background on my setup, because this is going to prefix kind of everything I'm going to talk about today. My setup, I use a MacBook Pro. Even though I'm a .NET developer and I work predominantly with Windows-based and Microsoft systems, I really like Mac OS. I find the user experience is really nice. The quality of MacBooks is generally pretty good. So I've been a MacBook user for a long time. I have a 2018 MacBook Pro. It's got a 4.1 gigahertz i7 processor, 32 gig of RAM. So not a low-powered machine. It's a pretty modest machine. I do use Windows, and I run Windows in a boot camp partition. That's just so I can sideload Windows against my MacBook. And I boot into that with VMware Fusion, so I can run my virtual machine alongside macOS, and I can kind of flip between the two simultaneously. For me, I use macOS to do all my emails and all my productivity, and Windows for my development stuff. On that Windows VM, I've got Visual Studio 2019. I have .NET Framework and .NET Core installed. I still work with .NET Framework, as I'm sure a few people here do as well. Even though it's kind of considered legacy now, a lot of the platforms I work with are still .NET Framework based. So can't quite move on from that just yet. I have a local SQL Server 2019 instance. Now this is particularly important. As I mentioned, I love to travel. I love to go around to conferences all over the world. I like to be able to boot up a project locally and run pretty reliably without an internet connection. So I need to be able to work on a train or a plane and run my project almost as I would expect. So having tight dependencies on infrastructure is a bit challenging, and that's why I have a local database instance. Of course, I do have cloud stuff as well. I have a VPN that I use to connect to Azure for security purposes. I've got all of my Azure infrastructure for all my hosting, database servers, web apps, functions, you name it. And I use GitHub for my source control. So where do we go next? We've got these really nice machines, but what does the next 10 years do? What's the next seismic shift going to be for developer laptops? Well, you don't have to look too far to see what's going on here. The MacBook Pro, for those that follow Apple news, the MacBook Pro that was recently announced with Apple's own custom silicon has blown other machines out of the water. It's an incredibly powerful machine in a very slim form factor. And the price is coming down too as they make more and more of these chips. It's an interesting thing where we might actually start seeing, far more powerful chips in devices, smaller, thinner devices, and at a lower price, which is going to mean that power becomes far more accessible. Equally, you don't have to look too far into other realms, and this has been going on for 5 or so years, that tablets and these other kinds of machines are becoming increasingly more powerful. In fact, the recent iPad Pros have got far more power in them than even the lower end MacBook Airs. So this is a really interesting move, that you've got a kind of single device that is a touchscreen experience, but it's got a fundamental large amount of power for ultimately what it does. It's not necessarily the most productive tool to be using, especially for a developer, but it is becoming more and more powerful, and I'm interested to see what happens with this. Also, look at something like the Surface the Surface Pro, or even the iPad that I'm showing here. You're starting to get mice and keyboards for these tablets. They're no longer becoming tablets. They're becoming these ultra-thin, ultra-portable, relatively powerful machines. So what does this mean for developers? Well, like I say, I want something that's powerful, so I can run all my dev stuff. I want something that's lightweight, that I can drag around easily. I'm not going to break my back with a huge bulky laptop in my backpack, and I kind of want to be able to work anywhere. I have become accustomed to the fact that I don't need several monitors, and I have an iPad actually that I use as a separate screen when I need it, but I generally have a lightweight, travelable setup. So I need all of these 3 requirements in my future dev machines. Maybe I'm asking too much. This is quite a lot. I want things to get thinner, more powerful, and more portable. There's going to become a point where that's no longer possible. So today I'd like to show you a couple of solutions that might be potential options to move away from this bulky hardware that we've got and instead move towards more lightweight shell devices. Let's take an iPad or a Surface Book as an example, where you don't need so much power in the actual machine, but you can have the power consumed maybe from cloud-based services or other options. I like the idea that maybe in the future I could pick up from where I left off on almost any device. So I don't need to have a laptop that I carry everywhere. I can have some kind of small portable device and maybe a desktop at home, and they will work simultaneously together. The first service I'd like to talk about is something called Windows Virtual Desktop. Now, this kind of concept has been around for a really long time. Enterprises, big organizations have had domains that you can log into for the longest time, like that they'd run on premise. So they'd have Windows servers running, Windows Enterprise servers running locally. A user could go to any machine in that organization, log into the domain with their user, and it would pull their profile down. So it's going to have the settings that they've configured. It's going to have their files, which would be coming from a network storage. It's going to have their all their preferences, the programs that they need to get their job done. Now, this hasn't been great for when we've kind of moved to this remote COVID type world where everyone works from home. People are having to remote into machines that are in a physical office. Having on-premise infrastructure for this doesn't really make much sense anymore. So there is an Azure service for this. There is the Azure Windows Virtual Desktop service, and it's actually bundled as part of Microsoft 365. So for an organization, they can spin up these services relatively easily. I'm going to just show you kind of how this is. Now, I've already set up a host pool for this because it takes about an hour to provision everything. So I'm going to walk you through kind of what setting up one of these environments looks like, and then we can discuss what's already been set up. So as I mentioned, you can create effectively clusters of compute in Azure that your organization can log on to with their domain, just like you'd have running locally, running on site, perhaps with your infrastructure. These are called host pools or virtual machine host pools in Azure. What you can do is once you've created one of these, it's kind of a collection of virtual machines that live underneath. And all this service does is manages the routing of where certain people's requests go, where traffic goes. You configure hosts and applications as well. We'll briefly touch on applications in a minute. Session hosts are virtual machines in Azure. So when I go into here, I can add a new host to my pool of services. You choose a region when you set up the host pool, and you choose how you want users to be split across those virtual machines, whether you want one of your users to log in and be assigned to a specific VM every time, or if you're happy for it to be pooled and they just get assigned to the nearest slot available on a virtual machine. So here I can configure the virtual machines I'd like in my pool. And of course, you can go a bit further. You can say, oh, I want it in this region. I want 10 VMs, and you can even configure the exact size of the virtual machine you want. Now, this is pretty powerful. Because I've pre-selected here, I can't show you that, but I'll create a new pool, virtual pool. You can configure the size of the virtual machine you want, and that's pretty interesting. Imagine if you wanted to say, we've got 3 or 4 departments in the company. We have our developers, we've got our admin team, we've got our sales team. Now, the developers are going to need perhaps far more powerful machines, because they're doing more complex tasks. Whereas the sales team, you may want to pack users in more tightly, or you may want to say, oh, actually, they can have a much lower capacity server. So you literally get the full free reign over choosing any of these Azure series of VMs. If perhaps your developers were doing more stuff with AI and computing AI models locally, well, you may want to give them something that's got maybe more powerful CPU, for example, whereas the sales team aren't going to need that. You can literally say this group of users in my Active Directory in your domain have access to these types of virtual machines, and we want to split them across this virtual machine, 2 per machine or 10 per machine. So I can kind of, for my developers, I say, oh, I'd like something with 8 cores and 32 gig of RAM, and I'm going to put 2 developers per machine there. So I'm going to need 10 machines, give it a prefix there. You choose an image, or you can upload your own, which is helpful for being able to roll out, changes. You configure how it lives within your network, so you actually have full control via a virtual network in Azure, full control over all of the networking rules that surround that. And you can, open ports up, do everything you'd expect to be able to do. Just to jump back to what I've already configured then. So I've got a virtual desktop environment here, and it's got 3 virtual machines inside. I've got IPs assigned to all of them, so I can, for the purpose of this demo, navigate into each of them. And this virtual network, which is set up to handle all of my routing. Of course, each one has its own network interface. If we look at my development environment then, just for a second, this is going to be the development environment we're going to try and replicate across a few different services today. I've got 2 solutions running here. I've got a sample .NET Framework solution. I mentioned I work with a CMS called Umbraco. This is an Umbraco .NET Framework solution installed, up and running, and I'm running it currently in IIS Express. As you see here, this is just a really simple kind of default Umbraco website. I can navigate around this. This is a typical website, typical web application. I've also got a .NET Core example solution running. This one is just the MVC sample app that you can install with .NET Core. As you'll see, it's got all of the configuration pipeline set up. It's got some views. If I jump into this one or index here, you'll see it's got a welcome. Of course, welcome, navigate around, and I can even make changes. So I can go and I can put an exclamation point there or something and say brilliant, refresh, and I should get my exclamation point. So this development setup with these 2 different solutions, I need to be able to access those from anywhere. This is running in Boot Camp on my Mac currently, but I'd like to be able to log in from my iPad and maybe work with this. Because I've set up the virtual desktop environment here in Azure, I have got I've remoted in this case to a virtual machine which is running on that network, and this has got the same 2 solutions open in it. I've just cloned these down from Git. So the profile that I've set up here for the image that my machines have, they all have virtual machine. They all have Azure. They all have Visual Studio installed, and I can run .NET Core and I can run .NET Framework apps. So I've got my sample Umbraco website, .NET Framework, all there, and you should see that one's up and running here. Can navigate around. Lovely, lovely. And my .NET Core sample too. Of course, it's down here. And just like before, I can make changes here. Of course, if I had some changes on my local bootcamp machine, in this case, I could make those, commit them, and they would appear in GitHub, which I could then pull from here. This is connected to the same Git repository. I could pull and be up and running relatively easily. So there's nothing too complex about this setup. It's no different to having 2 physical laptops. The one benefit here, though, is I can log into this virtual machine as many times as I need, and the same files are there because it's using a shared file storage. What's more, if you deploy this within an organization, Microsoft 365 organization, you can actually utilize the 1,000 gigabyte storage allowance that every single user gets. You can have full access to that as part of your subscription. So you don't need to worry about paying too much for, say, SSDs in Azure to do that. You can actually utilize the storage that every account already gets. So that's a nice cost saving as well, compared to having to provision terabytes and terabytes of disks. Of course, here I'm in a developer profile machine. It's got a moderate amount of power. Let's just have a look. Oh no, here isn't it? It's got a moderate amount of power. Nothing too fancy. Computer system properties. That's what I was after. So it's got 8 GB of RAM. It's got an Intel CPU, 2.6 gigahertz. This would be typically a low-powered Windows machine, but in that, I don't think that's too much of a problem. So yeah, the workflow here would be you can pull a repo, commit some changes, be up and running. Now, of course, this is no different to me just spinning up a VM in Azure at the minute, but by using the virtual desktop service, what you can do is expose access to all of these things via a number of alternative ways. So you can access directly in the browser and remote desktop into machines that way. There's even a handy iPad app, so I can spin that up directly on my iPad and interact with the touchscreen actually onto a virtual machine. That's pretty cool. Of course, it requires an internet connection, so if I'm working on a train, that's maybe not the best solution. I did mention I would touch quickly on something called virtual desktop apps as well. Now, the Microsoft 365 suite has got, I don't know how I can pull that up. It's got applications that will run directly. So while every time I log into a virtual machine, all it's doing is loading my profile and giving me access to my files, the applications, actually the state gets retained. So you could fire up a document on your desktop at home using the Windows virtual desktop application, the Word, let's say Office 365 Word, and you'd then be able to pick that exact same session almost exactly where you left off. You'd be able to pick it up on your iPad, on your phone, in the browser, on any other device. It gets all synchronized, which is quite cool. So like I mentioned, you can access this from absolutely anywhere. The benefit here is because it's just a virtual machine, you can install the exact software you need, whether that's part of an image that you then roll out to all machines, or if it's just something you've installed specifically for your user. This can be scaled elastically to your needs and the needs of your team, because you can say, well, the developer group has this power of machine and the admin group has a lower powered machine. All of this means it can be managed by an organization. Of course, if you wanted to replace your dev machine with just a high-powered Azure virtual machine, if you were say self-employed, you can do exactly that as well. It's no different. What this gives you is the ability to manage the whole cluster in one go. And I think probably the biggest selling point of this whole thing is you get full entire control of your network. It all sits behind an Azure virtual network, so you can control the inbound, the outbound, which ports are open and to who. So that's not something that some of the other solutions we're going to look at actually offer. So for an organization, I can see this ticking a lot of boxes. The downsides here, it does require a stable internet connection. I cannot use this solution working on a train or even a plane where there's definitely going to be no Wi-Fi. You do, because you're running virtual machines, still have to maintain them and manage patching and upgrade of those machines. And right now, this is restricted to US data centers only. So if you are, say, if you've got specific data sovereignty requirements, that's just not going to cut it in this case. You can spin the virtual machines up in other regions, but the actual management service lives inside the US data centers currently. Of course, the killer question, the million-dollar question here is, how much does all of this cost? Well, the virtual desktop service doesn't actually cost anything. The management service is free, which is really sweet. And like I say, can be bundled in with Microsoft 365 subscriptions. What you do pay for is the virtual machine capacity and your storage. So starting with a D2A virtual machine, 8 GB of RAM, 2 CPU cores, it's $70 a month. That's not cheap. If you work that out over, say, a 12-month period or a 2-year period, you're probably going to be paying about the same for a laptop. The benefit here is, though, you can start to squash people in on the same VMs. So imagine you went for one of these higher powered machines at 32 gig, or you can even go higher, and you could put 2, 3, 4 developers on a single host machine. which is quite cool. You do need to license your virtual machine, but that's included in the cost in this case. You could bring this cost down if you were to utilize something like the Azure Hybrid license, where you can bring your own licensing and actually get a reduction on the cost of your virtual machines. Equally, rather than using spot VM instances, you could have pre-purchased instances where you get a bit of a discount too. Okay, so that's hopefully a pretty typical setup that you'd expect. We've got a virtual machine sitting somewhere that we can connect to ultimately. There's just a nice wrapper around it that gives us different ways, different means of accessing it. The new kid on the block for something like this is something called code spaces. People have probably heard about this a few times. Code spaces started out life as a Visual Studio Online service, I believe, or at least it was part of Azure DevOps. So I think the most recent incarnation was Azure DevOps Code Spaces. The idea here is you could spin up access to a development environment directly in the browser. They've based the interface, at least, on Visual Studio Code, popular IDE, of course. The fact that that's written in JavaScript, it's actually an Electron app that you install on your local machine. They can run a large amount of that same UI and same logic in the browser, because it's just JavaScript. So Code Spaces allows you to spin up effectively an instance of VS Code in the browser, and it connects to your code running on a container behind the scenes. So all of the builds and all of the work that you're doing is actually just interfacing with a container environment running in the background there. That's kind of cool. Of course, this is now being rebranded, repurposed under the GitHub moniker. So GitHub Code Spaces will be the kind of the way going forward. This is exactly the same service with a few tweaks. It's currently in private beta on GitHub, and I've got a link a little bit later on for some details about how to sign up there if you're interested after this demo. Of course, let's just take a quick look. So I've got two repositories, as I mentioned here. I've got a .NET Core one and a .NET Standard, .NET Framework repository. These are simple. They've got all the files I need to get the solution up and running, checked in. In this case, I've actually got a embedded database running in my .NET Framework version, whereas this one doesn't need a database at all. It's just an MVC solution. Now, the way to get started with Code Spaces is this code tab on any repository. If you're in the beta, any repository on GitHub, you can go to this code tab, and you get the usual options of cloning, opening in desktop, downloading, but also a new one, open with Code Spaces. Clicking that then gives you an option to say, would you like to set up an environment for this? I've created one already, which I'll show you, but creating a new one is as simple as going create code space. Oh, I've reached my limit, of course. Create a code space and it will spin up the environment for you. It takes, depending on the size of your repository, anywhere between 30 seconds and 2 minutes, but it's pretty quick to get started. Of course, it's shut these two down, hasn't it? Been waiting too long. This will probably just show you actually how quick it is to boot one of these environments up. They shut down after 30 minutes of inactivity. At least they do on the beta. You can click a button, you can be up and running. So looking at this interface now, hopefully this is not a completely alien setup to you. We've got a Visual Studio Code-esque interface on the side. We can browse and navigate the solution. We can open the files up directly, see them, work on them, edit and change them. We have the terminal and we have, the full output window, everything we'd be able to usually see in VS Code. What's more, we've actually got access to extensions that you wish to use. So I've already installed a few here. I've got Docker, Azure access, but if we wanted to do a new one, there's a fantastic one called Fake Sharper. And I can install Fake Sharper. And this gives me reload. This gives me access to the it wraps around the ReSharper CLI. So if you wanted to use ReSharper in VS Code, this is actually a really nice solution. It's disabled currently. I've just disabled it by accident. But yeah, this is the solution. Of course, because this is based on the Git repo that I've opened up in GitHub, I have also access to the Git repository. I can go in, I can make a change, close the file, and it says, oh, you've got a pending change. I can commit it, add that file, commit it, and off we go. Then up here I can open this up, push, pull, do everything you'd expect to do. That's pretty sweet to have that integrated, and I'm just doing all of this directly in the browser. Unfortunately, this has spun up, GitHub Codespaces has spun up a Linux virtual machine. As a result, I cannot run this .NET Framework application. You'll see if I go .NET build, it's going to go, no, can't do that, found nothing to build, loads of errors, blah, blah, blah. So unfortunately for me, I can't run my .NET Framework projects currently in GitHub Codespaces. There's a small caveat to that, which we're going to discuss in a short moment. The .NET Core project, however, can run on Linux. .NET Core runs, of course, on cross-platform, and my solution here runs cross-platform too. This is the exact same thing I had cloned down before, but of course, I can go to .NET Core sample. I can run .NET build, and this is going to in the Linux container that's running in the background. It's going to run all of these commands. It's going to boot up that development environment that I needed. So it's built my app, and then I can run .NET run. Now you'll be thinking, how the hell do I get to browsing my application? Of course, I'm running in some random URL that GitHub has given me off the back of clicking a link on my repo. How the hell do I get up and running? You'll notice now I've ran .NET run. It's detected that the application has spun up a port. It's listening now on a port, and I can literally click a button and be up and running within moments. I say moments. That's odd. Maybe this doesn't work as well as I thought it did. That button at least. But anytime a port gets open and a URL is there pointing to that port, you can click a button and be up and running. So this is me browsing the exact application that I had running on my local machine now on this nice GitHub Codespaces URL. I can even make modifications. So I showed you here before that I modified this, and I put, I'll change this in fact, hello DDD exclamation point. Refresh, and this is proxying that container that's running in GitHub. So I can make any changes I need. Doesn't need to, restart or rebuild or even commit them. They just get up and running in seconds and minutes. That's pretty cool. There's more advanced features as well here, like you can do debugging and whatever else you'd like. Of course, I made a change. I can now stage that and commit it, but I'm not going to, and we'll see why in a minute. So as a quick summary of that, Codespaces runs in the browser. That's pretty cool. There's a choice of Linux. There is going to be a choice of Windows there as well. This is something that's in another private beta. Currently, in Visual Studio, there's a Visual Studio Codespaces experience being trialed where you can spin up Windows virtual machines. And my hope is that once that happens, we could actually run .NET Framework on those. If the host is Windows, we could technically install the .NET Framework SDKs into that virtual machine, into that container, and potentially build and run .NET Framework. So that's pretty cool. I love the fact that it's seamlessly integrated with GitHub. As I say, I use GitHub for all of my source control. And I like that I can literally click launch and be up and running within 30 seconds in the browser. I also love that Visual Studio Code extensions work because it's just VS Code. And even tools like ReSharper-ish can be installed with something like Fake Sharper. It does, of course, require an internet connection still. It's running in the browser. However, you can lose connection, and it's not, unlike, say, running a virtual machine, it's not going to totally disconnect me. Any files I've got open, I can work. Any commands I can run, but they just won't complete until my internet connection resumes, and you'll get a little pop-up to say that. So working on a plane, still not going to be possible. Working on a train when the connection's dropping in and out, definitely workable, I would say. Another downside, which is just something you've got to think about really, if you're used to working with containers, this is a no-brainer. But if you're used to pulling repos down onto a local machine and just booting it up in Visual Studio, maybe not so much. Containers, the container gets generated every time you open the code space from your repository, meaning if you have any files that need to be persisted and included in that solution in order for it to run, let's say media, or as I showed for the .NET framework, I've got an embedded database. They have to be checked in and included in that repo to appear in that virtual machine. Similarly, whenever you persist anything to the file system, maybe you create a bunch of temp files when your application runs, if those aren't checked in, you're going to lose them the next time you boot your code space. So my recommendation here would be you've got to have some kind of other external storage. That could be something like Azure Blob Storage or something similar. More so, something like a database, you're going to need infrastructure somewhere for that to live on. So rather than using embedded databases, you're probably going to need a database server that can connect up to that that code space. And currently, whilst it's in a private beta, there's no way of there's a set of IPs that you can whitelist, but they have to be public. You can't run a VPN, for example, and say, well, you need a VPN to connect to those databases. It's just not something that works right now. There's port forwarding rules, and you can configure a bit of the networking stuff, but you're relatively limited. And the final thing is you are limited to the platforms that are supported by the service. Of course, .NET Framework's a challenge. Equally, .NET 5 isn't there yet. What are we, 3-4 weeks in to having .NET 5? It's not quite there yet. It's a service that's in beta, so I appreciate that, but you are slightly limited to whatever the platform supports. Again, the million-dollar question, how much does this cost? Well, it's completely free for you to try out right now. If you go and sign up, you'll get access, hopefully before it launches next year. You can play around with it. It's completely free, up to two instances running, which is nice. It's about 10% cheaper than running a VM in Azure, I've noticed. So for a basic entry-level instance, they've got 3 tiers. Basic level would be $63 a month, going all the way up to $250 a month for a premium instance. You'll notice you've got starting with 4 gig of RAM all the way up to 16 gig, 2 cores up to 8 cores. People are going to be going, ooh, that doesn't sound like a very powerful dev machine. The thing that we're not having to pay for here, though, is the actual operating system. We're not paying for the host. You're paying for the power that's needed to run and build your container. That's pretty cool. Just like in most other cloud services, the benefit is we don't have to worry about the underlying infrastructure or the operating system. It's just there. I would say, having played around with this, the basic tier will actually be far more sufficient than you'd imagine. 4 gig of RAM to run and build an application locally. Chances are most people will be absolutely fine. Of course, you can go to the higher tiers too. This would be per account, so per developer in your team. This is what this is going to cost. And then again, you look at it over the course of 2 years, you're probably talking about a relatively high-powered machine, but you do get the benefits of being able to work from anywhere. Storage costs as well, they're about 10 cents a gig on top of these costs, but hopefully you can minimize that by having any essential storage elsewhere. Now, the final thing I wanted to discuss is kind of a combination of the two approaches here. It's something called Visual Studio or VS Code Remote. This is maybe a little known feature inside VS Code, and it's actively coming in Visual Studio as well. You may be familiar with the Live Share service that's available in Visual Studio and VS Code. This is based off similar technology. So VS Code Remote allows you to connect to any remote host, whether it's a container, whether it's an SSH service, whether it's a WSL service. You've got a whole bunch of options there where you can connect to remote infrastructure. And what that means is you can directly connect to a container running, let's say, on GitHub Codespaces, and you can boot that up locally and run locally, develop locally with maybe the tools that you'd like to have and like to be able to use, but the code and the build all happens on the remote infrastructure. I mentioned that this is available in Visual Studio, and it is. If I just dive quickly to my VM here, I've got the VS Code Visual Studio 2019 preview running, and you'll see a new option here, connect to a code space. This allows you to plumb the details in and get up and running. They're just checking, and I don't think I'm not in the beta, so I can't show you, but you can do it in VS Code. So VS Code, hopefully you're all familiar with this. VS Code has an extension in it called, where's it gone? GitHub Codespaces, magic. And it opens up this Remote Explorer tab. when one of these services is enabled. I'll just give those a refresh. It shows me all of the GitHub code spaces or containers or SSH services that I've connected up to my VS Code instance. It shows them all here, and I can choose which ones I want to browse to. It's as simple as clicking the power button next to one of these, and your code space is booted up live directly inside your VS Code instance locally. This is running on my Mac. I should mention that I don't have .NET installed on this Mac. I don't have anything, in fact, any language tools really installed on this Mac, only VS Code itself. It's by doing this, it's pulled down all of the extensions that I have installed in my code space. I showed you that. Got Docker and GitLens and a few others there, as well as the ones that I've got running locally. So I have access to all of those extensions, which is pretty cool. Equally, it knows exactly where I left off. You'll remember I made a change here. Welcome, hello DDD, and I didn't commit it. I made it a specific point of not committing it. Well, I can do exactly that now. I can do the commit and handle all of these this work exactly where I left off. The even cooler thing is when we go to the terminal, we can run all the same commands we were running in the browser. So I can do a .NET build. In fact, I need to change directory and call sample. I can do a .NET build, and this is going to, run the build. This is running in the code space, not on my Mac, because I don't have that installed. And I can go .NET run. This, just like before, has spun up a local process. It should have clicked that. It did. It's opened 5 of them. Brilliant. I think I can just go to localhost 5001. Perhaps not. No, for some reason it's not liking this at all. Let me just give it a quick kick and see if I can run that again. And if not, we will move on. It's not liking it. That's annoying. So to explain, this would spin up the exact same setup as we had running in code spaces in the browser. I would be able to go in here, make a change. I could see that in real time. It would be effectively just proxying the container that's running in the cloud. Same caveats apply. You need an internet connection, but VS Code nicely handles all of this. So if you've got files open locally, you can absolutely keep coding until you have an internet connection. Keep running commands until you are done. Ooh. And of course, it's decided to reorder all my windows. Like I mentioned, yeah, full control. You can have code spaces, containers, SSH, WSL. Because of this, because you can connect to containers, other containers, you could run a container on your own infrastructure even and connect to that. That's kind of cool. So you could use the VS Code remote service to connect to a container that you have configured and installed whatever you like inside. That could be, in my case, like Windows and ASP.NET Framework, so I can work exactly as I need, have all the tools. You can also install things like a local SQL instance in that container if you really, really want it. Because this is using VS Code locally on a machine, of course, at this point, VS Code is kind of just a shell, really, for what I'm doing. The power for running this isn't needed. I could run this on a really, really lightweight, notebook, and all of my dev power lives in the cloud, which is pretty cool. Yes, you still need an internet connection. Yes, storage in the container is still a concern. And yes, configuring access to your infrastructure is more of a challenge. You don't have huge amounts of control over the network and all of that configuration, unless you're running your own container, in which case you might. Okay, to quickly summarize, these 3 options I presented today, we've got virtual desktop environments. which if you're using the Microsoft 365 service, you can access through the browser, the desktop, on an iPad, or even physical hardware that you have in an office. That's no problem. Codespaces lets you interact with it through the browser, and also an iPad if you had a browser on there. It's pretty cool. It would be nice to see a VS Code app or Codespaces app or something for the iPad. I wonder if that's something that could come in future. And VS Code Remote kind of bridges that. You can have a desktop environment where you could connect to a Codespace. So you can have browser, iPad, or desktop through VS Code for a Codespace. The virtual desktop option does require a strong and reliable connection, so it's not really an option for if you're working on a train or something. Codespaces and VS Code Remote, they're a little more flexible. They handle it a bit better, so that's maybe more of an option. Of course, with the virtual desktop, you have full flexibility to install whatever you want. Codespaces, you do not. You're limited to by whatever the platform offers you, but you can kind of bridge that with VS Code Remote and run your own container with whatever you need installed. VPN access is challenging. If you have a virtual desktop environment, you can control all of that yourself, of course, because you have control of the network. Whereas the container-based option, you need the ability to configure those rules. And for Codespaces, it doesn't exist just yet. Whereas for VS Code Remote, you could have requirements that people install and run a VPN locally in order to be able to connect to things. But I don't know, it's probably going to get a bit messy. Finally, from a business point of view, I think virtual desktops makes quite a lot of sense because you can pack more people onto more machines and you can have different spec machines for different people, and you get a bit of a cost saving through that. Organizations have full control. They can roll out updates, implement restrictions and rules. Whereas with Codespaces, because it's a managed hosted service, you don't get that so much. However, I fully expect that there'll be, when it becomes generally available, there'll be some additional controls for enterprises in GitHub. GitHub Enterprise is a huge focus for them at the minute, so I guarantee there's going to be a bit more flexibility there. It will come, it's just not there right now. And the same applies to VS Code Remote. If you're running containers in your infrastructure, well, then your organization could manage those. If not, then it kind of relies on the individual. Some companies that would be good for. If you're just a freelancer, maybe that's a nice solution. But yeah, there's pros and cons for all of these options. I said I'd share a few helpful reading links, and here they are. So if you want to learn about Windows Virtual Desktop on Azure, there's that link there. Of course, this recording will be available and the slides will be available too, so don't worry about frantically jotting these down just now. The Codespaces preview to go sign up is this link, or github.com/codespaces, and I think you can sign up there. The VS Codespaces preview, again, there's a link there. This is something I'm particularly excited about because it unlocks the option for Windows virtual machines at some point, and that's where I really want to have a tinker. And Fake Sharper, a really cool tool if you're using VS Code but miss Resharper. Give that a go. And with that, I say thank you. You can follow me on GitHub or Twitter. I'll be available on Twitter and in the Q&A below to answer any questions now before the next session. Thanks so much.